In this screencast, we will talk about why someone should move from SQL Server to CosmosDB. It's more so moving from SQL to No Sql world. We will discuss about the advantages and benefit of No Sql, and we will talk also about the patterns and practices which we have learned in the SQL world, which we should not try to bring to the NoSQL. We should unlearn few things which helped us in past building the SQL Server applications. So before I start the screencast, I would like to put a disclaimer that I do love SQL Server. I worked in SQL Server for many years, built many applications in SQL Server, and I think it served us very well. So there are some applications which are a good fit for SQL Server and they should be left alone. But there are some applications which fit very well into the NoSQL world, where you have a requirement of very high throughput, low latency, and global distribution, and elastically they should scale to huge amount of data. In those requirements, I think NoSQL serves us very well. So the Cosmos DB is a multi-model database. By that it means you can store different kind of data into the Cosmos database. You can keep documents, you can keep graph data, and you can store table key value pair also. But in this screencast, we'll focus mostly on the document APIs of Cosmos DB, how you will store the documents, which basically addresses to the NoSQL solution. And the first and the biggest benefit of NoSQL solution I see is it brings the simplicity to the solution. Solutions become very simple. We'll talk more in detail, but this is number one, I feel. Number two is when you want to scale your application elastically, you want to keep scaling horizontally. Your data should keep growing from terabytes to petabytes. That's another place where NoSQL solution fits very well. So second is scaling. Third is when you want to globally distribute your data, so global distribution. Fourth is high throughput. It is very common to see in the Cosmos DB to see the throughput of 10,000 requests per second, 50,000 requests per second, 100,000 requests per second. It's a common occurrence in Cosmos DB world. And number five is requirement of low latency. And Cosmos DB gives us SLA for 10 millisecond read and 15 millisecond write. So let's see how the systems were built with SQL Server in 70s, 80s, or even in 90s, how we used to build the solution using SQL Server, and then we'll see how you can build the same solution with NoSQL in Cosmos DB and what's the difference. In SQL Server, in the backend, you will see the database with many tables. And these tables will have a relationship with each other, and the relationship can be pretty complex. There will be inner join and outer join and all that. And there can be many tables. These tables can be, from 20 to 30, 100, 200, 300, 500 tables can be there. And on this complex relationship of different table, on top of that, you will generally have stored procedure to deal with this complex table structure. So here's the layer of stored procedure. And in the database, you will have another thing called triggers. for table, which will fire on insert, delete, etc., and they will perform different actions on these tables and implement the business rules. And these tables will be so many tables will be there. The main reason is generally that time we used to normalize the data big time. So there will be a first form of normalization, second, third, even fourth form of normalization will be there in these table. And in 70s and before that, disk and storage used to be very expensive. So all this design was optimized to save every bit and byte. I remember having design meetings where we used to talk about what this column should be. It should be bit, or it should be an integer or a small integer or a long, things like that, because we wanted to save each and every bit and byte. And that design practices are still there. All these tables you will find mostly in these databases, they will be highly normalized. So this is the database layer. We'll call it backend. And then the next layer will be middle tier. And this middle tier layer used to be very complex, very big, because there will be a lot of business logic will be there in this middle layer. And in this layer you will have another complex thing which used to be called ORM, Object Relational Mapping Layer, ORM, and people used to use it to simplify their job, to convert from the data to object model. But this layer, ORM, itself brings a lot of complexity into the system. So this ORM talks to store procedure, and then data comes to middle tier. And there's another thing will be there in the middle tier, which will be a caching layer, because it was very expensive to go and get the data from databases. So most of the time we try to cache this data. And this all become more complex when you have a very scale out solution, because then this cache has to be distributed cache, and this middle tier have to be stateless. So this is middle tier. And then on front of this you will have your front end. And imagine if the front end requirement changes and you want to add an extra column in the backend, everything has to change. All this layer will be affected, middle tier, ORM, wrappers, store procedure. All these 3 or 4 places you have to make changes to accommodate one change in front end. And this design becomes more complex if you will realize that in big companies this front end will be done by one set of devs, and the middle tier will be worked on by one set of devs, and then the backend devs will be generally different set of devs. They are dealing with data and reporting. And here you will have other systems. There will be backend data warehouses, and you will have this cubes on which reporting will be based. So this is the SQL world. And now this is a one system, and imagine if you have to move the system at a global scale, then this database has to be moved horizontally to, say, different even continents. And then you have to have replication of data, and this middle tier becomes more complex because they have to know which instance of database they are talking. So any simple system turn out to be very complex by the end of the day. Now let's see how the same solution will be implemented in CosmosDB or in NoSQL world. So first thing happens is in the backend, in place of having these multiple tables, we will have these plain simple JSON documents. And these documents are very much denormalized. So I will say out of this 5 tables here, they will come into one document itself, because we want to denormalize, and all the information you need for a particular action is in one document. Now in front of this, so these documents are sitting in CosmosDB. So this is the layer or backend layer like before, but this layer is very smart layer. You don't have to worry about global distribution and scaling it horizontally for a massive amount of data and for all high throughput and low latency. All this comes out of the box by provided to you by the CosmosDB. And here in front of this you have your middle tier, which is a very thin layer. There's hardly any intelligence is there, because you don't want to do much data manipulation in this world, because all the data is kept in the document. There may be some duplication in these 2 documents, but there's not much manipulation. And when the front end asks for a document, you just basically call this middle tier layer, it gets the document, and the data comes back. Here's another simplicity. Now there is a change required in front end, and you just change this document. The schema, the JSON schema changes, and no change happen in your middle tier, because this is not very interested in what is there in the document. It just reads from the store and give it to the front end. So this way your design becomes very flexible. You can make changes and it doesn't affect much. You can keep adding to the schema and you can keep deleting things from the schema, and there's been no change needed in this backend store. So you see, it increases the simplicity. So this is the most beautiful part of NoSQL. It increases simplicity. There's no ORM layer here. You don't need. And caching, maybe you need a caching, but maybe you need a very thin layer of caching, and maybe you don't need a caching, because reading from backend is 10 millisecond. So it's as good as things are in cache. And because the design is as such, even if your data is in terabytes or in petabytes, this latency will be maintained of 10 millisecond. And the throughput is also very high. Like you can really literally go to hundreds of thousands of requests per second, and this backend will sustain all the load. Now you can see how simple the solution has become. And for reporting, you of course can start listening to these data feeds. You can get data feed coming out of this CosmosDB, and every change in the document can be captured outside by different systems. You can have maybe a Spark cluster here to process the data. You can have a data mart, or you can do some other processing and build your cubes if you need to. And you can go to some, say, Azure Event Grid. So if you want data back for reporting in some different format, you can capture all the changes happening to these documents, and you can move the data to different systems for reporting, and you can build your reporting here. Another thing I hear often, people complain that in CosmosDB you are charged by per collection, and it is not like SQL Server where you are charged for a SQL database and you can have however many tables you want there. You can have 50 or 100 tables, but this is not right. You cannot say that this collection in CosmosDB is one collection is one table of SQL Server, because this is a denormalized data. So it is possible that one document is your 10 or 15 tables in SQL Server. So first of all, this is not one-to-one mapping, and it is a good thing that we are charged separately for separate collection. The reason is maybe one collection has a requirement of, say, 2000 requests per second. So you can provision this collection for this throughput, and there's another collection which may be your master collection, which has just 100 requests per second, and you don't have to pay too much money to maintain this collection. So it is a good thing that you are charged by per collection, and you should not try to map one-to-one from SQL Server to this collection. First thing, you should unlearn of normalizing all these tables. Try to denormalize your data as much as possible, and that will keep your system very simple. I hope that it helped you to see the benefits of No Sql Solution, and you can see the pros and cons between two things. And if you have any questions, leave the comment below, and see you next time.